unmanned aircraft vehicle, drones, aerial photography. So aerial photography, we use it for the creation of digital maps. So it's really photographs of the ground from the camera pointing straight down. And so you can take these pictures from basically fixed-wing aircraft, helicopters, UAVs, drones, or balloons. And the cameras are triggered remotely or automatically. So here are some examples of air platforms. So 1862, there's a gentleman called Nadar in France who really started the first person to use camera on a balloon to take pictures of the ground. Okay, and then in the 1911, in the United States in Michigan State, somebody used a kite with a camera to take pictures. And really in 1914, World War I, they started to use planes for specifically aerial reconnaissance, to take aerial photographs of the enemy lines. And after the Second World War, the Canadian government had surplus mosquito bombers, okay? We had surplus mosquito bombers. And the Canadian government refitted these bombers for aerial reconnaissance in Canada, and we used it to generate our topographic maps in Canada. We're now seeing these drones. This is an octocopter, eight propeller drone that we can also use for aerial mapping. Okay, so this one is a school. This is my test flight with a DJI drone. This is my son's school, where he's teaching, actually. He's a teacher. And we did a test flight in Edmonton. And so this is an oblique view of West Edmonton, where Gary and I live. So in general, different types of air photos you can take. You can take what's called oblique, which is down. So we have oblique, we have vertical, panoramas, orthophotos. Geometrically corrected orthophoto. So the orthophoto is not just a photo mosaic. It is a photo mosaic that takes into consideration the third dimension, elevation. Geometrically corrected orthophoto is, it's not just a mosaic, but it's a mosaic with compensation for elevation. All right, so this is a sample of the ortho photo that we did for the school. We can talk about drones then. So some of the things we need to worry about when we're working with drones. So we need to make sure of safety, the rules and regulations, what is legal and not legal to fly the drone. And we need to understand the basic principles of flight, the physics of flight. And we will talk about what are the aircraft components, what are the pieces that make the aircraft fly. And then we will also introduce you to radio control flying. And then ultimately we want to use it to create aerial photographs. So in terms of safety, rules and regulations, so we are responsible, you need to fly in daylight and in good weather. So what are the good weather? We're really talking about you can't fly in the rain, and then we cannot fly if the wind is too strong. We should try to keep the drone in sight, line of sight, if possible. I mean, there's two reasons for line of sight. So even if you can't see, the drone is so far that it's small. What we mean by line of sight is that you do not want to fly your drone behind a mountain, because you may lose radio contact, okay? And if you lose radio contact, you may lose your drone. Okay, so in terms of safety checking, you need to make sure that the batteries are fully charged. That's probably the most important thing before you start a mission. And in Mongolia and Canada, we got to be concerned that it can't be too cold. And in terms of wind, we probably shouldn't fly if it's above, 20? If it's going to be gusting more than 20 kilometers an hour, you're taking a chance to fly. So we would recommend don't fly. So in Canada, if you're doing a commercial flight, special flight operations certificate, we need a certificate from the government. Okay, so there's two certifications. There's certifications below 2 kilograms. SFOC is above 2 kilograms. Now, when we first started last year, there was no regulations in Mongolia. I think there are regulations now. So as government employees, you need to just make sure that you're within the rules or you have permissions to do the flying. Yeah? So, okay, so then the other part is you need to respect privacy, people's privacy, right? Private property, and in terms of your photography. Yeah? So I don't think that the herders would be very mad at you if your drone scares away the sheep or the goats. Yeah? Now in America, there have been cases where people have actually tried to shoot the drone down because they were flying over their property with a shotgun. Yeah? Hey, so I mean, generally, if necessary, you should ask permission if you're going on to somebody's... Okay, so technically, we're not supposed to fly closer to 9 kilometers from an aerodrome, an airport. Tomorrow, we have been given a site for our field work that is within 9 kilometers of the airport here. But I have asked the government person, and he says it's okay. We're supposed in Canada fly below 90 meters. In US, I think it's 120 meters. I think we're going to try to fly higher than this here, but that's again, we assume that we have the permission to do that. Yeah? So you're not supposed to be closer than 150 meters to buildings, to people, animals, and buildings. Yeah, like in a park. And then certainly in the cities, the dense areas with traffic. Other restricted areas, definitely military bases is not a good idea, or prisons. Yeah. So do not interfere with first responders. What that means is, for example, in Canada, if there is a big car accident on the highway, you're not supposed to fly your drone to take pictures of the accident. Yeah. And in Canada also, when we have forest fires, you're not supposed to fly the drone because it interferes with the water bombers and other people working. Yeah. Okay, so basic principles of flight. So we're going to the physics now of flight. So basically, any aircraft would have thrust when it goes forward. There's drag, pulling it back, and there's lift, and then I guess the weight, pushing it down. So it's basically Bernoulli's principle of lift. And in the case of this is in the case of a wing, okay. In the case of quadcopters, basically the propellers act as the wings. Yeah. So in the case of the quadcopters, which we start off with, we have 4 propellers that lifts the craft, controls it. There is an intelligent flight controller, which is really a microchip board on board the aircraft. Okay. And it basically contains an IMU, inertial measurement unit. Okay. And an IMU, it's the next slide. So the IMU has 3-axis gyro, 3-axis accelerometer, and a pressure gauge. So I guess these gives the computer information as to which direction you're moving, right? The gyro, Gary? Mm-hmm. And the accelerometer tells it how fast you're moving and the 3 in the axis, the 3 axis, yeah? And the accelerometer tells you how fast you're moving, okay? And then the barometer tells you basically what height. Okay, the radio control transmitter, or the controller, basically talks to the drone. And in addition, inside the computer on this board, you have a GPS chip, which gives it the location, latitude, and longitude. And then some of the newer drones have also sonar in front and down, so that it can tell when it gets close to the ground, it can slow down. If it comes towards a building, it will stop or climb. Introduction to RC, yeah? Glider. So these are the different types of radio-controlled aircraft you can use. Glider, powered. So glider will climb if there is wind. So fixed wing is a plane, helicopter, and a quadcopter. So radio systems, basically the most common is 4-channel system with 3 servos. Gary will talk a little bit about the servos as it relates to the fixed wing. In our tough wing, there's only 2, right, Gary? Yeah. So only uses 2. Some of the other crafts have 3 or 4. Yeah. So in most aircrafts will have pitch, which is elevator, rudder with 1 stick, and then throttles the other. So these are 3 typical servos. In the tough wing, you have 2 servos and the power, right? So it's still 3 channels. Anyway, this is all technical radio control information. If you're interested, you dig into it. Most of us, we don't care. We just want to fly the drone. Yeah. Okay, so in terms of flight checklist, so, things we need to worry about, okay, more so even on a quadcopter, you're worried about the weight, the balance, and the alignment, and control surfaces, and control linkage. Gary will show you that with a tough wing. We'll talk about that a little bit. A lot of this is less of an issue with the drone, the quadcopter. So what you do have to worry about on the quadcopter or the DJI is the propellers are not too damaged by the operator. Introduction to quadcopters, okay? So right now we'll look at a detailed review of the unmanned aircraft for aerial mapping. So we already did that, all right? So now, quadcopters provide the most flexibility and cost effectiveness versus fixed wing UAVs. So that being the case, I think we now will have an opportunity to look at both fixed wing and quadcopter. One of the limitations of quadcopter, even though it's probably easier to fly, it's easier to land, the limitation is it cannot cover as big an area for mapping as a fixed wing. Okay, so in terms of when we did last year, we looked at the 3D robotics Solo was the best quadcopter for open source support and autonomous flight planning. We didn't pick this because there were some limitations with that because that is it's American made, so the parts have to come from America, and basically it was more expensive than the DJI. So we picked the DJI 3 Professional for Mongolia. Yeah? 3D Robotics and DJI have an agreement now that some of the 3DR products will be sold by DJI, right? Supply. I mean, the nice part about the 3DR Solo was open source support and autonomous flight planning with Mission Planner. Okay, now the bad part was it was more expensive and it actually had less. The batteries didn't last as long as the DJI. Okay, so it's more flexible for customization and mission planning, but it is more expensive and less time on the battery. Okay? So the DJI Phantom 3 Professional we picked versus the Phantom 4. At that time, Phantom 4 came out. We did take a hard look at Phantom 4 versus Phantom 3 Professional, and the rationale was the Phantom 4 had a better camera. It had more pixels, 20 megapixels versus 12 megapixels. Everything else was the same, but the disadvantage was the Phantom 4 encased the gimbal inside the body of the unit, and which made for, if you crash the unit, you have to send it back to factory to be fixed. And the Phantom 3, we could fix the parts separately without sending it back. So in the Phantom 4, this component is embedded inside the body of the Phantom 4. Okay? So when you crash, you cannot fix it yourself. You have to send it back. Phantom 3, if we have damage to the gimbal, we can just take it out and replace it with another gimbal. So the difference between the Phantom 3 Pro and the Advance, they have the same radio technology, they have the same batteries, they have the same engines. The only difference is the camera. Now the difference in the camera, for aerial mapping, the cameras are the same. For FPV, the Phantom 3 Pro will do 4K HD video. The Phantom 3 won't. Even in our case, we will never use 4K video. For aerial mapping, they have the same focal length, and they have the same 12 megabyte image. 4,000 by 3,000. Both of them are 4,000 by 3,000 pixels. In terms of, for our aerial mapping exercise, first of all, the Advanced is the same, gives you the same pictures as the Pro. The Advanced is cheaper than the Pro, and the Advanced and Pro is cheaper than Phantom 4. So in terms of the Phantom 4 giving you, say, 20 megabyte images, it really does not enhance the aerial mapping. It just makes the computation longer for the processing. So in terms of our research, the sweet spot for images is around 16, right, megapixel. Right now we're dealing with 12, the other one's 20. 16 is the perfect one, but 12 is okay. This is 12. The Pro and Advanced is 12 megapixel. The Phantom 4 is 20. Mm-hmm. The ideal size is around 16. Mm-hmm. So we're okay where we are. 20 doesn't give you any more benefits. The Phantom 3 is 1.2 kilos. So that is below the 2 kilogram limitation we have in Canada. So the size is about 350 millimeters diagonally. It can climb at 5 meters per second vertically up, and it descends is at 3 meters per second. It can hover vertically at around plus or minus 0.1 meter. Okay, when vision positioning is activated, and horizontally 1.5 meters. So if you're bringing the drone home and you slow down and stop, it would fluctuate, up and down. Mm-hmm. Theoretically, technically, with vision positioning is 0.1, without it's 0.5 meters, half a meter. And horizontally, it would be within 1.5 meters. What it means is it won't land exactly where you started from. It will be within 1.5 meter radius. And of course, all of this is affected by wind. Okay, the maximum speed is 16 meters per second. This is with no wind. The fastest the DJI will go is actually slower than the stall speed or the recommended speed of the fixed wing, yeah? Yep. So the fixed wing is recommended at 17 meters per second. Slower speed. So it has a maximum ceiling of 6,000 meters. We are here about 1,000 meters. So as long as you don't have any mountains above 6,000 meters, you're okay. Yeah. Operating temperature 0 to 40. Now I think it can go below 0, but they recommend between 0 and 40. So the GPS is GPS and GLONASS. Yeah. The maximum flight time, this is based on the batteries, is 23 minutes. We think it's a lot less than that, probably. I wouldn't push it past 18 myself. So when we do the flight planning, we have to be 18. Yeah. I would recommend 18 because the problem is if you have the drone coming back and you say, well, it says 23 minutes, you plan for 23 minutes. Well, if you're 3 minutes out and it goes to 0, it is a flying brick straight down. I would err on the safe side, make sure you have maybe a smaller flight area, but to make it come home in time before the batteries die. When we were trying it out last year in Turrelge National Park there, a few times I made a mistake with the mission plan, and we had to bring the drone back sooner than the mission. In fact, as soon as it starts to beep and give you a red warning, you send it home, because it's easier to put another battery in and fly the rest of the mission than to try and fix the broken drone. What you have inside the DJI 3 Advanced and 3 Professional is the same sensor. It's a Sony sensor, yeah? And it is a 12 megapixel sensor. Okay, I will skip most of the video stuff because we're only really worried about the photographs. So in terms of the field of view, this is very important for aerial photography, okay? So the aerial software, the processing software, like Agisoft and Open Drone Map, requires your camera lens focal length, okay, which gives you the field of view, all right? So that is the geometry of the imagery. It's very important. So you need to know the focal length of your camera. So ideally for an aerial camera, you do not want a wide-angle lens. You do not want too narrow. You want something in between. So in terms of sensitivity, this sensor handles 100 to 1600 ISO range. Yeah. So for the shutter speed, we're more interested at the 1/8000th, okay, 1/8000th of a second. So that's fast shutter. The image size, we should be very familiar with this. It's 4,000 by 3,000 pixels. Okay, so in terms of still photography, we're doing single shot. We're not interested in all the burst speeds and so on. That is something you can do if you are playing with the drone. But for now, we're interested single shot, 1/8, up to the highest speed is 1/8000th of a second. Image size 4 by 3,000 pixels. So we're really not interested in the recording modes. Just to give you an information, for the advanced, you can only do 1920 by 1080, and for the Pro, you can do up to what I call 4K. Okay, and for the advanced, you're limited to HD. So in terms of the SD cards, you need a class 10 or UHS-1 speed for the drone, or UHS-1. Maximum capacity 64 gigabytes. So out of the box, DJI supplies you with a 16 gigabyte only. So you have to buy another SD card if you want to do more pictures. Generally, the file format is FAT32 in terms of formatting the SD card. So generally, we recommend letting the drone format the card rather than formatting it on a PC and bringing it over. Sometimes that, for whatever reason, becomes incompatible. Okay? And then generally, we're saving it in JPEG. So this is the gimbal, and it has a range of -90 to +30. So the gimbal is the part that turns the camera up and down sideways. Again, this is, if you're using first-person view, FPV, and you're watching it, you can turn the camera as you're flying, yeah? Up and down sideways. When we're doing autonomous aerial photography, we don't have to do anything. The software controls. Okay, so the remote controller or radio control, the frequency is 2.4 gigahertz to 2.483 gigahertz. The older versions of the Phantom 2 and the early Phantom 3s used Wi-Fi range. The Phantom 3 Advanced and the Phantom 3 Pro, and I believe the Phantom 4 uses what is called Light Scribe. So for the Phantom 3 Phantom 2 up to the early Phantom 3 use just standard Wi-Fi technology. Phantom 3 Advanced, 3A, to Phantom 4 Pro uses a light scribe. So it's DJI's proprietary technology, which allows it to go up to 5 kilometers line of sight. They can fly the drone up to 5 kilometers away. If it is unobstructed, free of interference, that means line of sight, not behind a mountain, behind a building, then it is obstructed. Okay, so unobstructed and go up to 5 kilometers. Obstructed, they figure 3.5 kilometers. I would say that we will be limited to around 3 kilometers is where your real limit is. Okay, so operating temperatures again from 0 degrees to 40 degrees centigrade. And your battery, again, so the batteries, because you're using this special technology, the batteries for the Phantom 3 Advanced and Phantom 3 Pro and Phantom 4 are the same, but you cannot use older Phantom batteries. So you can mix the 3 Pro and the Advanced for sure, and I think also for the 4, but not for earlier batteries. For the radio control or the remote control, the RC, you cannot use older RCs to control the Advanced or the Pro. You need the same versions, okay? Because of the technology, the light scribe technology. Okay, so intelligent flight battery. When I'm talking now, everything I'm talking about in terms of the Phantom, I'm really referring to the Phantom 3 Advanced and the Phantom 3 Pro, not any other model, okay? So the battery capacity is 4480 milliamp hours. And then for the energy, it's 68 watt hours. So in terms of when we came on the plane, we have to take the batteries out now. You cannot leave the batteries in checked luggage, so you have to carry the batteries, carry on. And the limitation now, just so you know, according to the Chinese thing, is 160 watt hours is the max. I thought 100, but in China it's 160 watt hours. So if you're going to China, this is well under the maximum you can carry on a plane. So you're okay. So the other difference I forgot to mention, although it's the same battery, on the Phantom 3 Pro, you have a charger of 100 watts. And I think on the 3 Advanced, it's a lower wattage, so it takes more time to charge the batteries. Okay? So the Phantom 3 Pro charger will charge up the batteries, the same batteries, faster than the Phantom 3 Advanced. That's all. Okay, and then visioning. Okay, so the visioning positioning is, it only works if it's flying less than 8 meters per second. It only works if the drone is between 30 centimeters and 300 centimeters from the ground. The visioning only works if you have a lot of light. So in other words, they say you can't fly this at night. Okay, I think down below here we can see that for the charger for the Phantom 3 Pro, it's 100 watts. All right, so in terms of the application now, so the live view for the FPV, the mobile app is DJI Go. Okay, that's the application supplied by DJI. It uses 2.4 gigahertz. I know you only get 720p. This is on your tablet or your iPad. Okay, what you're seeing. And it will run on DJI Go, will run on ISO 8.0 or later, and the Android 4.12 or later. So when you buy the DJI Phantom, it does not come with basically the viewing part of the application. So you have to buy an iPad, or you have to use your Android phone, okay, or another Android tablet. So you need to make sure that the viewing device that you're using is compatible with the DJI. So you need to check. If you have already an Android tablet, you need to check on the list that it will work with the drone before you buy it. Or you may have to buy a new tablet to work. Okay, so this is basically the brains of your DJI Phantom. So you can call this the motherboard, and it would contain basically a board for your GPS, a board for your inertial monitoring unit, etc. Sensors, everything is on this board. So the good news and bad news is that the good news is if you crash your drone and you bust your board, you can replace it. The bad news is it's expensive. Yeah. So same thing with the gimbal. So with the Phantom 3, you can buy a new camera if you bang your camera on a rock. Yeah. So again, we picked this because the Phantom 3 camera and gimbal hang under the drone, and it can be replaced if it's damaged. The Phantom 4 is enclosed in the drone. If it's damaged, you have to send back to factory. So the DJI is set up, so there's the aircraft and then your controller. We will go through aircraft and the controller. We'll look at charging the controller and the batteries, mounting the propellers, turning on the controller, powering on the quadcopter, GPS and compass calibration, software and driver installation, configuration, firmware and software upgrade. So when you buy a new drone and it comes out of the box, we're going to do all this before we can go fly. So this is your radio controller and how it works. All right, so this is your TX or radio control. Okay, and the left stick. Okay, now out of the box, in North America we use what we call a mode 2 settings for your radio control. So when it comes out of the box, it's pre-configured to use mode 2, which is the common way we use the radio control. So the term mode 2 means that you assign certain functions to the joysticks. There's two joysticks, left joystick and right joystick. So under the mode 2 setup, the left joystick up down on the joystick is your throttle. And then left right is what we call the yaw, rudder control. So the left right button turns the drone, rotates the drone. Okay, so the right stick under the mode 2, if you push it forward and back or up and down, it is what we call pitch. Up and down would go forward or backwards. All right, this is a typical TX radio controller. Okay, and again, mode 2, what we call the throttle, rudder, elevation, and ailerons if you were flying a fixed wing. So this is a typical different units. So what we have here, if you are building a fixed wing with this radio control, these are the servos that you put on the plane. And when you do the rudders, you play with these throttles, it manipulates these servos. This part is on the aircraft, and these control these devices, which pulls and pulls different things to tilt the rudder, aileron, and so on. So different description here. If this is the left stick, if you go up and down, the aircraft will go up or down, right? And then if you go left and right, it would turn the aircraft, like we were saying earlier. All right, just a different way of describing it. And some of the different buttons, the gimbal dial, which is I think it's one of these buttons. I never use this, but there's some dials on top here. They will turn the gimbal, okay, if you're doing video. This does not have any propellers, so when we're ready, we need to put the props on. So just so you know, it is color-coded. And you got to make sure, very careful, that you put the right propellers in the right engines. Yeah? So you'll see on the drone itself, on top of the engine, there's a black dot and a white dot. So you need to put the propellers, the black propellers on the black dot, white propellers on the right dot. Otherwise, if you mix them up, it will not fly properly. So the batteries go in, and it only goes in one way. You push once, it tells you batteries are all charged up. And if you don't do anything else, you turn off. Now, to actually initiate the battery, you do one push, then you push again, and hold until it's all green. So you can see that the front of your plane when the batteries are on is red, and the black is flashing. So this is the gimbal guard. When you're carrying it around, when you finish your flight, you need to make sure the gimbal guard is on so that you don't damage the gimbal. Okay, so to turn it off, same thing, you push once, and you push and hold. So then to pull the battery, squeeze the two slotted areas, and then pull. It's an intelligent battery. And for the controller, do the same thing. You push once to see how much charge. 4 bars. So we want it to be turned on properly. You push once, push once, push and hold. Now it's on. Okay? A red light means it's not connected to the aircraft. When it's connected, it will turn green. So turn off, push once. When it's blinking, push and hold until it goes off. Should always try to turn off the batteries so that it doesn't discharge completely while it's in the box. So batteries and charging. So charging, this is your charging unit. This is a 3 Pro. So it is a 100-watt charger. You have a 3 Advanced. So that's a 75-watt charger, so a little smaller, takes longer time to charge. So this piece fits the battery. This piece for the controller. You should only charge one. You should only charge the controller or the battery, not together. So they don't recommend charging both together because I think it affects your charges. If you're doing a mission, we used up all 3 batteries. I don't think we can do a field charge. You have to come back, charge both. DJI sells an adapter that allows you to put up to 4 batteries to be charged at the same time. Okay? So you don't have to unplug and then plug. But it still takes, an hour or 2 per battery. It'll just charge one at a time, but you can leave all 4 on. Go to bed and it'll be all charged in the morning. But if you have just one, you got to unplug and plug. It doesn't do all 4 at a time. It will pick one, charge it, turn it off, pick another one, charge it, turn it off. So you just don't have to keep unplugging and plugging, that's all. But it takes the same amount of time, all right? Doesn't save you time, saves you hassle. After all the batteries are charged, then you need to do what is called GPS and compass calibration. So basically what it needs to do is the computer unit, there's an IMU unit inside the motherboard. So it needs to know that it is horizontal. So you have to go through a calibration. So when you hook it up, if it's out of alignment on the computer, it will tell you on the software, the DJI Go software will say you need to do a calibration. And when that happens, you should then follow the instructions and it will describe how to rotate. So this, you're going to rotate it horizontally. So they suggest you do this. And then the lights will beep. And then you're going to go vertical and you're going to do the same thing. Okay? Then the computer will reset the IMU. And then you're ready to go. If we were going to fly this, first thing you got to do on the controller is to make sure that your button, there's a button up here on the top, has 3 settings. Left is F, middle is A, and right is P. Well, F is the mode you set for autonomous. P, make sure that it's locked to the GPS. Then you turn this on, So you always fly in P mode because P mode is controlled. So the GPS, once you have GPS lock, in the P mode you could just raise it with your throttle, it'll fly up, and it'll hover with GPS. Okay? And then when you push it forward, it goes forward, backwards. Okay? So it gives you a lot more control unless you become much more experienced. Anyway, and then I guess the last thing you do, you go through checklists. It'll tell you good, bad. We'll later on do that. So you have two ways of starting and stopping the engines. Okay? So one way is to use the up arrow button here on the DJI app. Then you need to slide it over. So when you pull the two buttons into the middle, at the same time it'll start the engines. And when you pull both down to the middle, it'll also stop the engine. Okay, so now we can just power down. It's power down, same sequence. Reverse sequence of what you started with. Yeah. Okay, so when you're done, you take the props off, put it in the box and all that kind of stuff. Yeah. Okay, so remember to start and stop the motors, you bring in the two joysticks. In and down. So it's in and down or in and out. Either will work, but it's both down. Yeah. And then lift the joystick up to increase the throttle. And then in an emergency, there's the return to home button. So the basic imagery, what we want, the information is stored on the micro SD card. And the flight data is stored inside the computer, the motherboard. And you need to download it. If you need to download the information, you need to use a USB. So this is us in the field. I brought actually a little drone, okay, to play. So without GPS, that was extremely difficult to fly. I need somebody 12 years old with very good fingers to work. Yeah. Okay, so this is us with the drone and simulation. So this is just working within the group. Assuming we do all this stuff, we have it calibrated, we have the batteries charged, we have a SD card that has got a lot of memory, and we're ready to go out in the field with a mission, and we do a mission. When we finish the mission, we come back, I'm going to do post-processing. So one of the things you need to know is that when we do the mission, we are using DroneDeploy, and I'll show you very quickly, hopefully before lunch, DroneDeploy, to set up the mission. Then basically, you do not use the DJI Go app. You use DroneDeploy app on your Android or iOS to connect to the device, and you fly it. So it would then initiate a flight path, a mission. Direct down aerial photos will be taken. Image, in our case, will include EXIF data. EXIF data includes geolocation, latitude and longitude, camera and photo specification. So DJI Go, DroneDeploy, and these other software automatically uploads the geolocation data, the GPS data, to the photos that is being taken. Yeah. If you are not using the DJI camera, you have a separate camera, which you can also do, then you need to use the GPX data from the drone and GeoSetter to load the EXIF data to the images. So this is an example of the photos from the DJI drone from this machine. This is a zoom-in image. So 4,000 by 3,000 pixels. So this is, if you look at the image, this is what we call EXIF data. So it tells you your f-stop, f2.8. The shutter is 1/799 seconds. ISO 142, focal length 4 millimeter. So the focal length is fixed, for the camera. All right, and the most important part we need is the latitude and longitude. So this comes out of the GLONASS GPS inside the drone. So each image has a geolocation point. Without this, we cannot process the ortho photo. Okay, so DJI Go, when we did this, it doesn't have autonomous flight support. You need to be at the location to create a waypoint. So then we have DroneDeploy, has autonomous flight support. You need to connect to the DJI, and you upload the mission data to the drone, and it will fly. So DroneDeploy is free. Anybody can use it. Now, Map Pilot, you have to pay, and it only works for iPad. What we will train you on here for this training is we're going to use DroneDeploy for now as the mission planner. Gary will show you mission planner for mission planning on the fixed wing. That is not available for DJI. That's why we're going to use different products, applications. So post-processing is to do, if we want to create the ortho photo, then we have commercial off-the-shelf applications. So the two that's available now that is good is Agisoft PhotoScan Professional and Pix4D Mapper Pro. The problem with these is they're quite expensive, and I could not persuade the Canadian government to buy the professional for us. But for Ministry of Environment, they will pay for the standard. So we will use the standard. Okay? So the difference is there's more features in the professional, much more features, but for just mapping, we can use the standard. Yeah, this we will do on Friday. Yeah. And then we have also cloud-based, which is DroneDeploy. We will show you DroneDeploy as well. I've got up to this slide. So for free open source applications now is Open Drone Map is available, and it works, but it only works on Linux. With Agisoft, we created this ortho photo. This is, again, the field work. We're laying in, I guess we're trying to put in ground control. On this trip, we're not going to use survey-grade equipment. Gary has some handheld GPS we'll use to just do some less accurate ground control, but we'll do some ground control. So in essence, then, basically, direct down photos from UAV. Images should include EXIF. We can use these, etc. Yeah. DroneDeploy and mission planning. All right. So mission planning for the DJI. DJI Go does not support autonomous mission planning for their drones. Okay. So the DJI GS Pro, I discovered that there was actually a GS Pro that would support iOS 9.2 or later, but it only works for the iPad. So we need to, Jonathan, download. We have iPad. You may want to download the DJI GS Pro. So, but there are commercial applications for Android and iPad, include Map Pilot, which is only for iPad, and Litchi, which is for both. Okay, these are commercial. Now, for now, DroneDeploy is the best option, and it's easy to use. It does what we need. I will continue to use it. Yeah? There's another application called UGCS. That is another option. It is like Mission Planner. It's open source. It is the problem with Mission Planner, you'll see when Gary explains it to you, it is very complicated, and DroneDeploy is much easier to use. And unless we need all the functionality of Mission Planner or UGCS, I would stick with DroneDeploy. The DJI GS Pro Mission Planner, okay, for iPads. Now the other one is UGCS. The problem with UGCS, again, it is commercial product. So the Open is free. The One is actually quite cheap. I haven't had time to play with it to say I recommend it or not recommend it, but it's available. Okay, I'm leaving that for now. And then we have DroneDeploy. Okay, this is DroneDeploy. We used it last year for the work we did in the national park, and we will use it here again. The DroneDeploy app for your mission planning is free. For now, anyway, it's free. But their business model is they sell you web map processing service. DroneDeploy Explorer is free, but they really geared towards North American farmers that want them to process a lot of data. Pro is $99 a month, or business is $299. In our case, we don't need to use their mapping service, so we will use their mission planning application, which is free. But we can use their free Explorer option to do some testing and sample map processing. So you can see that you can do free 5 a month on their website, through their website. You can use up to 500 pictures now. 500 pictures. We will never get 500 pictures based on the battery time on the DJI. So one mission, we would run about 200 to 250 pictures per mission. So maybe if we do 2 missions side by side, then we have 500 pictures. Yeah? So they will give you up to 5 centimeters pixel only, smallest. I see absolutely no reason to have a need of even 5 centimeter pixel, but who knows? Okay? But so that's not a limitation for us. That's fine. So DroneDeploy summary then, it's free to sign up, supports both Android and iOS. We have unlimited mission planning. It allows irregular map area selection, supports all DJI models, and you can use up to 5 web maps a month if you want to use their web service. Yeah. Okay, so we can do an online mission now before lunch. I would suggest that if you like to, you can go to the website and sign in, create an account for yourself. So the way you would do this is you come into DroneDeploy, all right, and you can use this map. You can zoom and pan manually, or you can zoom in. Here's where we are. You can go and start a new mission. Okay, let's do that. Let's say we want to map the university. So according to my laptop, we're around here. We're actually in this building, I think. Okay? We want to do a mission here. Let's say we start a new mission. Okay? So we click on the plan of flight. This is an untitled plan. There's university. We can call this University. Okay, this is the project. Now, it's just automatically laid out something for me, and maybe I don't want that one. So I'll zoom out. Let's say I want to do the university, but I also want this area. So we can delete it. So with this, let's see. Okay, so I want to fly this area, or to map just this area. What it tells me is that at 75 meters, to fly this line, 1.8 minutes, it's 25 hectares. Size is 32 centimeters. Not too bad. It is not my drone, it's their drone. So it says it needs 2 batteries for their drone. So for now, let's say, I'll just show you some characteristics. Okay, so the green line is where the drone will fly. This is assuming it's running at this point. If we launch the drone from here, it will have to fly to this point before it does the run. And it would have an altitude of 75, this is flying at 75 meters. So when we say, okay, I don't want to fly at 75 meters, I'll fly at 120 meters. So at 120 meters, it only, at that it only takes 8.9 minutes to fly. I have a 5 centimeter pixel size. So the higher you fly, the bigger the pixel. Right? If you want to have the smaller pixels, you come lower. But if you come lower, then there'll be more flight lines. Right? Suppose if we have the wind now, so we have direction is 0 degrees. If we have wind coming from the east, say, we want to fly perpendicular to the earth. We can change our flight direction to perpendicular to the wind. Now the other thing is that under the advanced, so side lap, front lap, 65. So this is the overlap of the pictures to make your ortho rectification mosaic. So if you change these parameters, then the lines change and the number of pictures change. So if we're happy with this, then we can test the similarity. So when the drone is connected, in our case to this, you'll see an aeroplane at the bottom here that tells you the drone is connecting, like just like your light. All right? And then